Hi, my name is Gushan, and in this video I'll demonstrate internal and protected internal access modifiers in C#. In the previous video, we discussed what access modifiers are, and we saw the demonstration of public, private, and protected access modifiers. In this video, I'll demonstrate internal and protected internal. If you define a type or a member to be internal, then that type or member can be accessed anywhere within the assembly in which it is declared. It cannot be accessed outside of the assembly. A protected internal access modifier is a combination of protected and internal access modifier. If you recall from the previous video, a protected member can be accessed within the class in which it is declared and from the derived class. An internal member, as we were just discussing, can be accessed anywhere within the assembly. So putting both of these things together, a protected internal type or member can be accessed anywhere within the assembly in which it is declared or from a derived class in another assembly. However, the access from another assembly must take place within a class declaration, and this class should derive from a class in which this protected internal member is declared, and it must take place through an instance of derived class type. So keep these things in mind. Let's look at a demonstration. Here I have a project from the previous video in which I had a base class within which I had three fields: a private, protected, and a public field. I had a derived class that inherited from the base class, and within this derived class I was only able to access the protected field and the public field. I cannot access a protected field and a public field. I cannot access a private field outside of that class. If I scroll down further, within the main method, I create the instance of the base class. Using this instance, I am only able to access the public field. I cannot access private field or protected field because this class isn't inheriting in any way from the base class, so I am unable to access a protected field in this class. Now let's look at an example of internal and protected internal access modifiers. Within my solution explorer, you can see here I have just one project within this solution, and that is Access Modifiers, which I created in the previous video. Now for this video's demonstration, I'll create another project. So right click on this solution, go to Add, select New Project. From the dialog box that opens up, from the Windows desktop, I select Console Application and then give this application a name. I'll select a class library rather. Let's select a class library, and we'll give this class library the name of something like Assembly1 and click OK. So we have this new project which is a class library added within this solution, and now you can see this solution has two projects. And within this class library we have this namespace Assembly1 and this empty class named as class1. So first of all, I'm going to give this class a meaningful name, something like, let's call it Assembly1 class1. And within this class I'll create three members. Internal member, I'll call it int my internal field. Protected internal, let's call it my protected internal field and a public field. My public field. So this class has three fields. One is internal, one is protected internal, and the third one is a public field. Now let's create another class within the same class library solution, class library project, public class, and I'm going to call this assembly1 class 2. Now this is a second class within the same assembly, and this class is not inheriting from the class 1, so they are both separate classes. And within this class I'll have a method, call it my method, and within this method I'll create an object of class 1, assembly1 class 1, and let's call it object equals new object there. Now using this object, you can see I have access to internal field, protected internal field, public field. Going by their definitions, an internal field can be accessed anywhere within the assembly. A protected internal field can be accessed anywhere within the assembly. A public field can be accessed anywhere. It has no restrictions. So all of these three fields are accessible outside of this class. Internal field can be accessed anywhere within the assembly in which it is declared. A protected internal field can be accessed anywhere within the assembly in which it is declared. And a public field has no restrictions, can be accessed anywhere within the assembly or even outside of the assembly if this assembly is properly referenced. So these three fields are accessible outside of the class. Now within the same solution, let's create another class library. Add a new project. Let's call it assembly2. Alright, so now we have three projects within the solution, and within this assembly2 we have this class 1. So again, I'm going to give this class a meaningful name, so let's call it assembly2 class 1, and this class inherits from the assembly1 class 1. So this class inherits from this class. Okay, so it inherits from assembly1 class 1. So this assembly1 class 1 is an unrecognized literal in this project. If I move my cursor over this, you can see that the assembly1 class 1 could not be found, and it is giving us a hint. Are you missing a using directive? A using directive are these ones at the top, or an assembly reference, or maybe we are missing an assembly reference which are within the references in your solution explorer. So at this point we are missing a reference. This project or class library has no link to assembly1. If you are trying to access a class that is within the assembly1 project, we have to provide a reference within the assembly2 project. So to provide a reference, you within the assembly2 project, you right click on references, click add reference. From the dialog box that opens up, from the left panel you select solution, and then within that we see we have access to two other projects in this solution. So we have access to Access Modifiers which was there already, and the assembly 1. And now we will select assembly 1 because this is the project that we want to provide reference to assembly 2 project. So I select assembly 1, click OK, and now there you see within the references we have a reference to assembly 1 project. Alright, but still you see that our error has not gone away. It's the same error, assembly 1 class 1 could not be found. Are you missing a using directive or an assembly reference? We have given assembly reference. So what are we missing? We are missing a using directive. Let's add a statement for that. So using assembly 1, there you go. And right now, as soon as you add that statement, you see that the error has gone away. Now this project knows what assembly 1 class 1 is and is able to access that. So within this assembly 2 class 1, let's create a method, private void my method, and within this method we'll create an object of class assembly 2 class 1, recall from the slide, and it must take place through an instance of the derived class type. So we need to access the members of the base class through the derived class type. So we need to create an instance of derived class assembly 2 class 1, and I'll call this object. Now using this object, let's see what do we have access to. We have access to protected internal field. So from the definition, you can access a protected internal field outside of the assembly within the derived class. So this derived class is inheriting assembly 1 class 1 as the base class, and the protected internal field within this class is available to this derived class, even though this derived class is in a separate assembly. And I also have access to public field. Public fields have no restrictions. They can be accessed anywhere, provided you give a proper reference to the project. So within the assembly 2, we have given the reference to assembly 1, so we are able to access the public field in this assembly. Let's create one more class. We'll create another class, public class, and we'll call it assembly 2 class 2. And this class doesn't inherit from assembly 1 class 1, so this is a separate class within the assembly 2 project. And then within this we'll have a method, public void, I'll call it my method, and then I'll create an instance of assembly 1 class 1. Let's call it object equals to new. So now within the assembly 2 class 2, we have an object, an instance of type assembly 1 class 1. And now using this object, I only get access to the public field. I do not have access to protected internal field. My protected internal field. Right now it's not showing us any error message, but if I go ahead and build my solution, it's going to throw us an error message saying that my protected internal field is inaccessible due to its protection level. There, so we got the error message. I cannot access protected internal field in this class because this class is not inheriting from assembly 1 class 1. It's a separate class altogether. So we cannot access a protected internal field in this class. However, there is no problem accessing a public field Again, going by the definition, public fields can be accessed anywhere within the assembly, outside the assembly, if they are properly referenced. Okay. If you do not provide access modifiers for the types or the members, C# provides a default access modifier. So let's look at some of the default access modifiers for different types. Namespaces cannot have access modifiers. It's not allowed. Namespaces have no access restrictions. So as an example, here I have this namespace assembly2. If I try to provide even a public access modifier, I'll get an error straight away. A namespace declaration cannot have modifiers or attributes. So public, internal, you cannot have any of these. You cannot have private. None of these can be used with the namespaces. Top level types. So these types are the ones which are not nested in other types. By default, they have internal access modifier, and they can have either internal or public access modifiers. So top level types are, within the namespace I have this class. So this class is a top level type. Similarly, this class is a top level type. I can, if I do not specify any access modifier for this class, by default it will be considered as internal. And nested types, which are members of other types. So within this class, these methods, properties, fields, or even a class within the class, they are all nested types. By default, their accessibility level is set to private. So if you look at the table down here, class, interface, struct, enum, the default access modifier for them is internal if they are defined as a top level type. And at the top level type, they can have either public or internal access modifiers. Members, as an example, let's say class members, by default, if you do not specify any access modifiers, they are considered as private. And they can have any of the 5 access modifiers: public, protected, internal, private, or protected internal. So that's it for today. I hope you enjoyed this video. Thanks for watching. Have a nice day.